Hello everyone. Today we will continue the discussion of Chapter 2 of The Introduction to Data Mining by Pang Ning Tan. But before that, let's have a recap of what we have discussed in our previous lesson. In Lesson 1, we discussed all about data, datasets, attributes, and objects. In the discussion, we defined certain terminologies and the different types or classifications of these terms, like yung data, on different types of data, different types of data sets, different types of attributes. And last time we also discussed about the 4 data-related issues important for successful data mining. We enumerated 4. First is the type of data. Second, the quality of data. Third, the data pre-processing. And fourth, the measures of similarity and dissimilarity. In Lesson 1, we discussed the type of data. In today's lesson, which is Lesson 2, we will be discussing issue number 2, which is the quality of data. Now, under this topic, we will be discussing the measurement and data collection issues, measurement and data collection errors, and the issues related to applications. Data mining applications are often applied to data that was collected for another purpose or for future but unspecified applications. For that reason, data mining cannot usually take advantage of the significant benefits of addressing quality issues at the source. In contrast, much of statistics deals with the design of experiments or surveys that achieve a pre-specified level of data quality. Now, because preventing data quality problems is typically not an option, data mining focuses on, first, the detection and correction of data quality problems, and second, the use of algorithms that can tolerate poor data quality. Now, yung detection and correction of data quality problems, we also call it data cleaning. Okay. Now, in the following discussions, we will be tackling the specific aspects of data quality. But we will focus our discussion on the measurement and data collection issues, although some application-related issues will also be discussed. So we'll discuss first with measurement and data collection issues. Of course, it is unrealistic to expect that data will be perfect. There may be problems due to the following: the human error, limitations of measuring devices, or flaws in the data collection process. Values or even entire data objects may be missing. So, isang number 1 problem is missing values or data objects. And sometimes, nagkakaroon tayo ng duplication of data objects or spurious objects. Multiple data objects that all correspond to a single real object. Halimbawa, there might be 2 different records for a person who has recently lived at 2 different addresses. Even if all the data is present and looks fine, there may be inconsistencies. So, the third problem that we will be discussing is the inconsistent data. So, a person has a height of 2 meters but weighs only 2 kilograms. So, inconsistent. So, how can a person be 2 meters high pero yung weight niya is 2 kilograms lang? Okay po? 2 meters ka tapos ang weight, ano na lang yung buto-buto lang yun o mga skin lang. So, sabi nga, these are the problems and these are the reasons or the causes of the problems. Measurement and data collection errors. First, let us define the following terms. Measurement error refers to any problem resulting from the measurement process. A common problem is that the value recorded differs from the true value to some extent. For continuous attributes, the numerical difference of the measured and true value is called the error. The term data collection error naman refers to errors such as omitting data objects or attribute values or inappropriately including a data object. For example, a study of animals of a certain species might include animals of a different related species that are similar in appearance to the species of interest. Both measurement errors and data collection errors can be either systematic or random. Sometimes these errors may be done on purpose o kaya sometimes errors are done accidentally. In this discussion, we will only consider general types of errors. Within particular domains, there are certain types of data errors that are commonplace and there often exist well-developed techniques for detecting or correcting these errors. Sabi ko nga, data cleaning ang sagot sa mga errors na ito. Now, many data entry programs have techniques for detecting and correcting errors. Pero, ano ba yung mga data quality problems that we normally encounter? We have the following, yung noise and artifacts, precision, bias, and accuracy, outliers, missing values, inconsistent values, duplicate data, issues related to applications, like timeliness and relevance. Now, let's start with noise and artifact. This is not commonly heard yung mga words na to. Commonly heard sila pero ibang meaning. Pero in our case, in our subject, slightly different sila sa common words na noise at saka artifact. 'Di ba pag noise sa atin is, we mean ingay, which is actually somewhat the same as the meaning with our topic for today. Tapos yung artifact, alam nyo yung mga hinuhukay, mga artifacts. Okay, 'di ba? Yung mga gamit na nahuhukay nila, pangalan nito, yung mga Indiana Jones, ay mga artifacts, 'di ba? But let us discuss what noise and artifacts are. Amen. Pag sinabing noise refers to the random component of a measurement error. It may be meaningless, unwanted, or corrupt data. Pag sinabing noise, it may involve the distortion of a value or the addition of spurious objects. For attributes, noise refers to modification of original values. May relation din siya doon sa common term na noise, na ingay. Ibig sabihin kasi hindi yun yung desired mo na sound, 'di ba? Kapag sinabing noise, hindi yun yung desired sound, hindi yun yung gusto mong marinig. Meron kang gustong marinig at ngayon sumasama tong ibang sound na tinatawag nating noise. Okay. Example ng noise is the distortion of a person's voice when talking on a poor phone and snow on television screen. Gumaganon. And the magnitude and shape of the original signal is distorted. So if you may consider this, this is an observed signal of two sine waves. Hindi ko na nilagay yung dalawang sine waves na tapos pinagsama. Basta ito na yung product nila. This is a sound wave. Pinagsama yung dalawang sound waves and then this is the product. Pero kapag may noise, ito ang itsura niya. What do you observe? Diba? Dito, malinaw na malinaw yung linya. Pero dito, hindi mo na alam alin yung totoong linya. Ito bang nasa baba na to? Pero bakit may mga iba-iba pang tusok-tusok dito? Which is, yun yung mga tinatawag nating noise. Dapat clear lang. Ito yung talagang message or ito yung talagang sound or signal. Pero ito ngayon ang lumalabas pag may noise. Marami naman tayong devices ngayon to avoid noise. Tulad nito, itong ginagamit ko microphone, noise cancellation microphone. So, somehow may mga devices tayo na ginagawa, lalo na dini-device ng mga engineers, just to avoid this noise. Now, sa mga images naman, what's noise? Sabi, consider the three groups of points below. Ito yung group 1. Kitang-kita mo, clear na clear yung divisions nila. Alam na alam mo kung yung point na yung saang grupo nakabilang or where that point belongs. Ito, bawat point, alam mo kung saan siya nabibilang na grupo ng mga points. We have three groups of points here. Very distinct. Okay? Alam na alam mo, madidistinguish mo kung saan naka-include yung bawat point. Now, the inclusion of unwanted data that makes the grouping of points difficult to distinguish is shown in this figure. Look at this. Meron mga points. Actually, points yan. Nilagay lang ng para malaman nyo na siya yung mga noise. Now, ito. Dito ba to or dito? Or may sarili siyang grupo? Ito. May mga sarili ba silang grupo? Wala. Kalat-kalat. Hindi mo madidistinguish saan siyang grupo. Saan sila? Para saan ba sila? Okay? So, these are noise. Ibig sabihin, unwanted naman sila, hindi naman sila kasali talaga. Pero nasasama sila. If you may still remember my example before in lesson 1, yung sa bird's eye view, sa resolution topic natin na pagka bird's eye view, yung far away from the object that you wish to look or to picture, or to capture, yung image na gusto mo i-capture, masyado ka malayo. So, the resolution of your, may be very smooth, very fine. Pero may mga noise. Ibig sabihin, may mga ibang images surrounding it or yung mga environment na hindi naman necessary or unwanted naman yung mga images na yun. Pero nasama doon sa picture simply because of the distance from the image. Okay? So, yung mga objects na yon, yung mga that actually belongs to the environment and not to the image itself, sa desired image, those are noise. Okay? Now, artifact. Ano yung artifact? An artifact refers to deterministic distortions of the data. It is a data flaw caused by equipment, techniques, or conditions. This one naman is distortion of the data due to equipments, techniques, or conditions. So, more or less, kung meron kang gamit, o kaya meron kang mga techniques na ginagamit or mga equipments, na wala ka ng ibang equipment kundi yun lang, magiging, ang tawag dito, hindi mo to maiiwasan. Okay? Mga artifacts. Common sources of data flaws include hardware or software errors, conditions such as electromagnetic interference, and flawed designs such as an algorithm prone to miscalculations. Take note po, ito mga dinidiscuss natin. These are flaws, these are problems na common naman sa data mining. Kaya nga tayo nagkakaroon ng tinatawag nating data cleaning. Hindi natin maiwasan ng mga problemang ito, kaya ang gagawin natin ng solusyon. Precision, bias, and accuracy. Ano ba to? In statistics and experimental science, the quality of the measurement process and the resulting data are measured by precision and bias. Now, what's the precision? Pag sinabing precision, it is the closeness of repeated measurements of the same quantity to one another. It is often measured by the standard deviation of a set of values. Bias, on the other hand, is a systematic variation of measurements from the quantity being measured. It is measured by taking the difference between the mean of the set of values and the known value of the quantity being measured. So, sa bias, kailangan alam mo yung true measurement, yung true value. And i-differentiate mo siya or i-minus mo siya from the mean of the set of values na makukuha ninyo. So, mean meaning average. Okay? Accuracy refers to the degree of measurement error in data. It depends on precision and bias, but no specific formula in terms of these two quantities. Now, if you may notice, in the definition of these three terms, makikita nyo na merong mga repeated measurements. So, it is not only, you cannot see the precision, the bias, and accuracy based on one measurement alone. Makikita nyo, this can only be done if you have repeated measurements. If you have a number of different measurements or different data, different values. Kailangan marami kang values para malaman mo kung anong precision, ang bias, and ang accuracy. And sabi ko nga sa bias, you have to know the real or the true value of the quantity being measured. Now, let's have an example for bias na lang. Suppose we have a standard laboratory weight. May isa kang weight. And then, ang original mass, known mass is 1 gram. Now, weight 5 times with the following, weighing it 5 times with the following value obtained. Ito yung first weighing, second weighing, value on the third weighing, on the fourth weighing, and on the fifth weighing. All of these, of course, are in grams. Di ko na nilagay na grams yan. Now, if you want to know the mean of these values, you just add all the values and then divide it by the number of times you have weighed the laboratory weight. Okay? Ano yung weight? Yung pabigat. Okay? Sa mga nagbabarbell, may mga weights. Okay? Now, so, ang gagawin mo sa given dito, since this is an example, you add all the attempts or weight attempts, and then, ito na, all the values, add all the values, and then divide it by 5, dahil 5 yung 5 times mo siyang winay. Then, you'll get 1.001. So, ito yung average or mean of the 5 masses or weights. Now, bias is just the difference between the original and the mean values. Original value minus mean value, or mean value minus original value. So, this is, ito, since ang original natin is 1.0, so 1.001, which is the mean, minus the original 1.0, will get 0.001 grams. Okay. Now, for accuracy and bias and more examples, please refer to the following resources. Ito lang yung mga nakuha ko. And Google, of course. You can Google for other help. Katulad ng mga sa YouTube. May mga discussions about precision, bias, and accuracy. And of course, yung mga deviations. Yung average deviation, standard deviation, andun din. We will discuss all this in a later topic, yung mga deviations. Outliers. Ano yung outliers? Okay. Outliers are either data objects that, in some sense, have characteristics that are different from most of the other data objects in the data set. Or values of an attribute that are unusual with respect to the typical values of that attribute. Alternatively, we can speak of anomalous objects or values. There is considerable leeway in the definition of an outlier, and many different definitions have been proposed by the statistics and data mining communities. So this is not just the only definitions, kahit do sa ibang terms natin. Now, sometimes outliers are noise that interferes with data analysis. Okay? Or sometimes, outliers are the goal of our analysis. Okay lang ba yan? Okay. Example natin sa fraud and network intrusion detection. The goal is to find unusual objects or events from among a large number of normal ones. Ngayon, syempre, sabi, di ba, yung unusual objects, yun yung hahanapin mo. Yung sa case 2, kung yung unusual objects ang hahanapin mo, this, ibig sabihin siya yung goal of our analysis. To find for the unusual, yung kakaiba dun sa mga data mo. Pag nakita mo kakaiba, baka merong intrusion. Okay, so madidetect natin intrusion. That's one use of outliers. Sometimes naman, these are just the noises, yung nag-i-interfere yung outliers. Mas maganda kung gamitin natin outliers as the goal of our analysis. Now, to show what an outlier is, or just to illustrate outliers, eto siya. Halimbawa, we have this data, mga values, ayan. Sumusunod naman siya, hindi siya nalalayo dito sa line na to, na dapat naman na siyang behavior, pero merong nalayo, medyo malayo ang values niya compared sa iba. O, ito yung tinatawag nating outlier. Okay po? Kaya nga outlier. It lies outside. Okay? Missing values. Now, what are the reasons for missing values? Alam naman natin kung ano missing values, nawawalang value. Reasons may be information is not collected. Like for example, people decline to give their age and weight. Or nakalimutan, nalaktawan ng tao, meron siya pinifila pa ng mga forms, nalaktawan niya yung isang data na dapat niyang filapan, yung isang information, nalaktawan niya, so hindi niya nabigay, hindi rin napansin nung nag-interview or nung nagpapa-fill out ng form. So, may missing value ka na agad. Or attributes may not be applicable to all cases. Example, annual income. It's not applicable to children. So, pag may interview kang children, dun sa, sa barangay nyo, meron kang, sa database ng barangay ninyo, merong annual income. Children are not working yet. They have no income yet. So, wala silang annual income. Dun sa field ng annual income, kung meron kang children na nandun, hindi applicable sa kanila yon. Okay, mga tambay na walang trabaho, so walang annual income. Those are two of the reasons. And siguro may iba pang reason for missing values. Meron sigurong nabura. Ayan, pwede yon. Missing values kasi nabura nung nag-enter nung data, or hindi na yung mismong pwede kasi deliberate. Kaya lahat ng ito pwedeng deliberately done or by accident lang. Okay? Strategies to combat these missing values. First, eliminate data objects or attributes with missing variables. So if you have a research or a study being done, pwede mo na gawin na eliminate mo na lang yung data objects ng maraming missing values. Or to estimate or interpolate missing values. Halimbawa, na-read mo yung, time series of temperature. Na-read mo yung temperature for the first hour, the second hour, tapos na-miss mo sa third hour. Pero sa fourth hour, nakuha mo ulit yung temperature. Sa fifth hour, nakuha mo ulit yung temperature. So, meron kang 1, 2, 4, and 5 readings. Time 1, time 2, time 4, time 5. Readings ng temperature. Pag kinuha mo yung mga differences, nung halimbawa 1 to 2, 4 to 5, at medyo, alam mo, halimbawa, ang temperature tumataas ng 10 from 1 to 2. From 4 to 5, same thing. At saka from 3 to 4, from 2 to 4, parang 20 yung taas ng temperature, 20 degrees. So, malamang-lamang, mahuhulaan mo na yung third hour is i-interpolate mo lang, i-ano mo lang na by tens pala ang taas ng temperature. So, pwede mo nang ilagay na halimbawa, ang sa first hour mo is 10 degrees, second hour 20 degrees, fourth hour 40 degrees, and then fifth hour 50 degrees. So, alam mo na yung third hour, malamang-lamang na 30 degrees ang reading. So, pwede yan, interpolation. Now, ito, ignore the missing value during analysis. So, these strategies may be done. Tulad nga nito, yung just ignoring, many data mining approaches can be modified to ignore missing values. For example, suppose that objects are being clustered, and the similarity between pairs of data objects needs to be calculated. If one or both objects of a pair have missing values for some attributes, then The similarity can be calculated by using only the attributes that do not have missing values. So, ignore mo na yung mga may missing values. It is true that the similarity will only be approximate, but unless the total number of attributes is small or the number of missing values is high, this degree of inaccuracy may not matter much. Likewise, many classification schemes can be modified to work with missing values. So, example pa nun, let's say, missing values, halimbawa, age gaps ng mga mag-asawa sa kapitbahay nyo. Pwede mo nang sabihin yung age gap ng iba nyong kapitbahay. Halimbawa, 10 ang kapitbahay ninyo na malapit sa inyo, na na-interview nyo. Yung isa, yung 3, hindi na ibigay ng mga misis nila, yung mga age nila, ayaw ibigay. So, meron na tayong missing values. Pero yung 7 na couples, kumpleto. So, ang ibigay mo na lang kung ano yung meron. So, yung sa 7 na lang na couples, yung age gap ng 7 couples. Most likely, yung result naman nun is parang, na rin, pwede na. Okay na. Hindi na magiging 10 couples yung in-interview mo na ibibigay mo result, kundi yun na lang 7. Kuha nyo po ba? Okay. Now, inconsistent values. Data can contain inconsistent values din. Halimbawa, transferring the data, reasons nito, pwedeng transferring the data from one medium to another, tulad nung nabanggit ko kanina. You have written it, and then nung tina-transfer mo na, ini-encode mo na, nagkamali ka ng typing. So, inconsistent values. Halimbawa, yung zip code mo, zip code ng Tondo 1, Tondo 2. Ayan, Tondo 1, Tondo 2, 1013 tsaka 1012, tama ba? 1012 and 1013. Ngayon, dahil nag-encode ka, hindi na binigay sa'yo kung ano, kabisado mo lang, Tondo is 1012 tsaka 1013 ang zip code. So, lagay ka na lang ng lagay. Pag minsan, di mo kabisado yung anong street ito, Manugit. 1012 ba to? 1013. Yung Dagupan. 1012 ba ito or 1013? So, hindi mo alam. Lagay ka na lang ng lagay 1012, 1012, 1012. Alam mo kasi District 1 is 1012. And the District 2 is 1013. Ang problema, hindi mo kabisado alin yung sa District 1, alin sa District 2. So, pag minsan, maitatype mo na 1013 yung isa, 1012 yung isa. Pag nakita ng isang tao yung address na may Tondo, maguguluhan sila, bakit may 1012? Bakit may 1013? So, hindi nila alam. Dalawa talaga yung zip code. Okay, sa Tondo. Kasi may Tondo 1, Tondo 2. Hindi naman kasi natin nilalagay normally sa address natin na Tondo 1, Manila. Hindi. Halimbawa, 1621 Antonio Rivera Street, Tondo, Manila. Ganun lang. Hindi mo sinasabing 1621 Antonio Rivera Street, Tondo 2, Manila. Walang ganon. So, maguguluhan kung hindi sanay yung taong titingin or yung analyst na titingin sa data natin, maguguluhan siya, inconsistent yung values. Bakit may zip code, Tondo, tas may zip code na 1012. Tondo, pero may zip code na 1013. Which is which ba? Very inconsistent yung values. But actually, the values are correct. Kaya lang, inconsistent sa name. Name is Tondo. And then, 1012. Sometimes name is Tondo, pero 1013. Okay po? Pwede ding reasons for inconsistent values natin yung using different significant figures. Lagyan ko nga ito ng ilaw para makita nyo. Okay. Using different significant figures. Okay. Ito, most likely sa ano to nangyayari? Sa conversion. Okay. Nung nagtuturo pa ako ng thermodynamics, physics, and everything, ng math, lagi kong binibigyang diin yung significant figures. Yung number of decimals needed. Pag nagko-convert po, tsaka pag nagpapakompute ako, I always tell them to consider at least 5 decimal places or 5 significant figures. Ayoko na mas maliit doon. Ayoko ng 2 lang. Kasi may mga conversions na napakaliit, lalong-lalo na kapag science sa pinag-uusapan natin. There was a time ano to? Sa NASA, merong isang malaking project. Pina-convert nila yung weight or yung mass ng isang object, ng isang heavenly body sa pina-convert. Parang bagong ano yata yun, a star or something. May ilalagay sila doon na kailangan mag-adapt doon sa mass. So, pina-convert yung mass from pounds to kilogram, I guess. Pero ang ginamit lang is 2.2. 2.2 pounds per kilogram. Bago lang kasi yung taga-compute nila. Pero of course, tinatry muna nila yun. Di naman nila basta ina-apply. So, when they tried it, sa sarili nilang, anong tawag doon? Tinry nila yung anong tawag doon? Yung hindi totoo. Kalimutan ko yung term. Yan. Sumabog. Bakit? Kasi 2.2 pounds per kilogram lang ang ginamit nila na conversion factor. When in fact, pinakamalit na dapat yung 2.205. And it's not just 2.205, may karugtong pa actually yon. Pero medyo pwede na yung 2.205. Malaki po ang effect ng 0.005 na value sa computation. Lalo na kung malakihang numero ang pinag-uusapan natin. Halimbawa, i-convert mo yung 1,000 kilograms. Iba pag kinonvert mo lang yung 1 kilogram sa pounds. 2.2 pounds daw per kilogram yung iba. Iba naman 2.205 kilograms. Pero what if 10,000 kilograms ang pinag-uusapan natin? Planeta ang ayon sinasabi ko sa NASA. Sa 10,000 kilograms, ilan dapat ang in pounds? Convert nyo nga. Okay? So, ilan? 2.205. Ilan yun sa 10,000? 1, 2, 3 ang movement, 4. O, di 22,050 pounds. Ang layo, di ba? Hindi natin pwedeng yung 50 pounds. Hindi mo pwedeng baliwalain yun. Sa 10,000 kilograms pa lang yun. What if we are talking about 1 million kilograms? So, sa 1 million kilograms, yung 500 or 5,000 pounds, malaking difference yun. So, yung use of different significant figures greatly affect your data objects, yung values ng data objects. So, magkakaroon tayo ng inconsistencies doon. Okay? Duplicate data. Data set may include data objects that are duplicates or almost duplicates of one another. Pag sinabi mong duplicates, more than one copy of the same data. Now, major issue when merging data from heterogeneous sources. Examples, same person with multiple email addresses. So, kapag pinadalan mo ng letter sa email nila or ng email, yung isang tao, ang dami-dami niya nare-receive. Iisa lang naman siya kasi multiple email addresses niya. O kaya, different people with same name. Nagkakaroon ng duplicate data. Okay? Different people siya with same name, lalagyan mo, kaso hindi mo na alam kung sino siya. Magkakaroon pa ng inconsistent values doon dahil akala mo ibang tao. Akala mo same person, pero magkaiba pala, kaya magkaiba yung addresses nila, magkaiba yung phone number, etc. Pero mas malala tong duplicate data na same person siya with multiple email addresses, or same person yung padadala mo, same email address, kaya lang nagkaroon siya ng 2 records or 3 records dahil lang sa spelling of the name. Okay, that's causes of duplicate data. So, we will be needing data cleaning. This is the process of dealing with duplicate data issues. Data cleaning, yung i-correct mo yung mga mali. Example niyan, ang madalas kasi yung sa encoding. Yan ang madalas na mga dumalabas yung error. Okay, mga data issues sa encoding talaga. Human error lagi. Bihira yung dahil sa, yung kanina sa outliers, yung dahil sa mga machines, sa equipments. Mas madalas human error. Now, for inconsistencies or issues related to applications. Now, data quality issues can be considered from an application viewpoint as expressed by the statement, data is of high quality if it is suitable for its intended use. Sabi mo, ang ganda-ganda ng data ko, kompleto yan. Kompleto, depende sa kung saan mo siya gagamitin. Sometimes, hindi mo naman kailangan ng age. Kinuha mo lahat ng age, nagpakahirap ka pa sa interview, lahat ng age ng mga lahat ng in-interview mo, pati yung mga kamag-anak nila, it will require you some time, additional time to get the information, and yet, hindi naman pala kailangan. Okay, sa relevance sa papatak. So, what are the issues related to applications? We have timeliness and relevance. Now, pag sinabing timeliness, some data represents reality for a limited time only. Lalo na kung, alimbawa, katulad ngayon, ano bang magandang example dito? If the data is out of date, then so are the models and patterns that are based on it. Say, for example, nagkaroon ka ng research about, nagkaroon ako ng friend. Ito na lang example ko. I had a friend na nagkaroon siya ng research, ng pag-aaral, gumawa siya ng bagong program, nagkulong siya for how many months? 1 year yata or 6 months sa bahay niya. Ayaw niya makipag-usap, dinadala lang siya ng pagkain ng misis niya. Yan, programmer siya. Way back 90s to. Programmer siya, nagkulong siya sa bahay for a year dahil very passionate in programming. Nag-create siya ng isang program. Actually, tapos nung lumabas siya para ibenta na yung program na nagawa niya, ang galing-galing. Lahat na ng data na lahat ng ni-research niya, tsaka yung kinuha niyang data, ginawa niya, nag-create siya ng isang program. Tuwan-tuwa siya kasi kakaiba, ang ganda. Ibebenta niya, alam mo, nakita niya, ginagamit na sa mga companies. Alam niyo po kung ano yun? Windows. May kaibigan ako na kapag program siya ng katulad ng Windows, pero syempre wala pa siyang nun. Gagawa niya, kukuhanan niya pa lang ng patent. Nakakatuwa. Paglabas niya, ayun na. Ginagamit na sa mga companies. That was 1995 if I'm not mistaken. Yeah, 1993. That was 1993 na magkakilala kami. So, kagagaling niya lang sa kanyang pagkukulong. Nung makita niyang gano'n nangyari, delayed na palang, late na sa technology yung kanyang ginawa. So, ang ginawa niya na lang, nag-apply na lang siya as programmer doon sa company kung saan ako nagtatrabaho. That's why naging mag-friends kami at naikwento niya yon. Visit na visit siya kasi sinayang niya yung 6 months to 1 year niya para lang mag-program. So, timeliness. Okay? Maganda yung nagawa niya, but wala siya sa timing. Late na siya. Late na. Okay? So, timeliness is an issue related to applications. Relevance. The available data must contain the information necessary for the application. Sampling bias is a problem that occurs when a sample does not contain different types of objects than in proportion to their actual occurrence in the population. So, yung sa relevance, yung katulad ng example ko kanina, relevance o yung halaga, importansya para dun sa pag-aaral na yon. Yung katulad ng example ko kanina, you're getting the age of all the people that you're interviewing, pero hindi naman pala relevant to sa study mo. Hindi ka gagamit ng age doon. O kaya, kailangan, kukuha ka na, mas mahirap kunin ng mga data. mga SSS number, pinipilit mo magkaroon na lahat ng SSS number lahat ng tao dahil gusto mo gawin yun yung gusto mong gawing primary key mo para sa database mo, and yet hindi naman pala importante yung SSS number nila dahil yung iba GSIS ang number, wala silang SSS relevance. At kakailanganin ba talaga doon sa study mo yun? Di naman pala. Ang kailangan mo lang is if you are having a research about the average family income. Ano mo yung SSS dun? Wala, hindi ba? You have to just interview about ano yung mga trabaho nila at magkano sweldo nila ng mga tao. Hindi mo kailangan ng SSS number. Those are just Now, for the knowledge about the data, ideally, data sets are accompanied by documentation that describes different aspects of the data. The quality of this data and documentation can either aid or hinder the subsequent analysis. Say, for example, if the documentation identifies several attributes as being strongly related, these attributes are likely to provide highly redundant information, and we may decide to keep just one. Okay? If the documentation is poor, however, and fails to tell us, halimbawa yung missing values for a particular field, then our analysis of the data may be faulty. Other important characteristics are the precision of the data, the type of features, like halimbawa yung in lesson 1 yung nominal, ordinal, interval ratio, the scale of measurement, halimbawa meters ba ito or feet for length, o kaya kilograms ba ito or pounds for mass, and the origin of the data. Those are some of the facts and dito mga aspects of the data that somehow we need to know. Okay? We need to know. We have to have the knowledge about the data. So, I think that ends our discussion of lesson 2 for our chapter 2. I hope you have learned something, and next topic is about data pre-processing or pre-processing of data.